It's a NEET 2020 question in gravitation. The problem is like this. What is the depth at which the value of acceleration due to gravity becomes 1 by nth of the value on the surface of the earth? So let us try to write the equations for that, right? The earth having a mass m, radius r, on the surface of the earth, the relation between gravitation can be found using this weight acts in downward direction mg, that is equal to that is due to the gravitational force between the two bodies, that is g mm by r square. So relation between small g and capital G is nothing but gm by r square. I have equated these two because this weight is also due to the gravitational force between the bodies. I got this relation on the surface of the earth. On surface, when you go into the earth at a depth from the surface, when you go to a depth at the surface, this is the entire earth. We want at a depth d from the top, where the radius of the earth is r itself, mass is m. So at this depth, what we can notice is the entire mass of the earth is not acting on the small particle. So G equal to G, total mass of the earth, is not a valid equation here. I have to convert that into other forms, where I can write density equal to mass by volume. Volume of the spherical earth is 4 by 3 pi r cube. So mass can be written like 4 by 3 pi r cube and rho. Then G can be written like G 4 by 3 pi r cube rho by r square. This r square and r square in the numerator will cancel. So in the depth we have to write relation 4 by 3 pi g r rho. This is a proper relation at a depth. I cannot use this relation like that what we have on the surface of the earth, right? So this is over the surface, the same formula over the surface, right? So we can write at a depth d, g dash becomes 4 by 3 pi g, as entire radius is not acting, only this part is acting, that will become automatically r minus d. That's a acceleration due to gravity, and of course so at a depth. It is given that at what depth, that question is at what depth acceleration due to gravity is 1 by 1th of the value g on the surface. At depth means we have a relation 4 by 3 pi g r minus depth into rho 1 by n of, on the surface I could write g equal to gm by r square, but I will write in the similar terms. That itself is transformed into this shape. These both are same, but this is more appropriate to write here. 4 by 3 pi g r and rho. Now densities will cancel. 4 by 3 space will cancel. Capital G also will cancel. What is remaining is r minus d equal to 1 by n of r. So r minus r by n equal to d. So if I have taken r common, 1 minus 1 by n equal to d. R of n is the LCM, n minus 1 equal to d. That's the answer. At a particular depth, R of n minus 1 by n, acceleration due to gravity, is 1 by n times at a particular depth when compared with the surface. That's how we have to solve the problem. So to solve this problem, I need to know some basic aspects. we need to know some basic aspects. First aspect is G equal to Gm by R square cannot be used when you are going for a depth because entire mass is not available here. So we shall express it in terms of radius and density in this format. This is on the surface. When you go to the particular depth, distance from the center to that point becomes R minus D, then I have to use this formula. And I have just used the condition that was given in the problem and got the answer, whatever is given in the options. That's how we have to solve the problem. It's a simple problem based on the formula that is due to gravity. That's how we have to solve the problem. Thank you for watching.